These are the frequently asked questions for Algebra 2 first section for 8 day 2, starting with number 29. And in number 29, we have that situation where we need to use the complex conjugate because we have an I in the denominator, and I is the square root of -1. So you'll notice the first and the last terms are exactly the same. It's just the sign between them that is different. And then whatever, of course, we do to the bottom, we have to do to the top to keep our fraction equivalent. So the bottom is what I was focusing on to get rid of the I. That's where I'm going to start. And I'm going to do first times first, which will give me 1. But outside times outside is going to be a -4i, and inside times inside is going to be a +4i. And those are going to cancel each other out. So I'm not going to worry about those. And then last times last will give me a -16i squared. So that will be 1 minus 16 times -1, because I squared is -1, which will actually make it 1 plus 16, which is 17. In my numerator, I do some FOIL, and I get -4 plus 16i plus 3i, and then minus 12i squared. We can combine some like terms. We have two I terms, so it will be -4 plus 19i minus 12, and then remember I squared is a -1. So it's really going to be -4 plus 12, which would give us 8, and 8 plus 19i. And if they ask us to write this as a complex number in standard form, we would split it up and put the real part of 8/17 in front, and then 19/17 and an I in the back. So that would be A plus BI. And usually when you are to work with complex numbers, you are supposed to put them in standard form when you get done. Number 31 has 4/2 minus 3i. Again, this is a situation where we need to use that conjugate because we have an I in the denominator. So we're going to need to multiply the top and the bottom by 2 plus 3i this time, because that's going to be the conjugate of 2 minus 3i. And again, focus on your denominator first. First times first is 4. Outside times outside plus inside times inside will cancel each other out if you've done this correctly. And then last times last would be -9i squared. Well, we know that I squared is -1. So that will actually give us 4 plus 9, which is 13. Let me move this up a little bit. Then we're going to distribute the 4 across the top, and that will give us 8 plus 12i. And there's nothing else we can do with that except bring it along for the ride. And then at the end here, we can write this in standard form by real part first, and then imaginary. So 8/13 plus 12/13i for number 31. Then on the next page, we have some solving of the equations, and number 34 has 2x squared plus 1 equals 0. So I would want to just go ahead and solve this because there's no middle term, which means I need to isolate the variable. So I'm going to subtract 1 from both sides and then divide by 2. And now I have to take the square root, so that will give me the positive and negative square root of -1/2. Well, I'm going to split that to see what happens. So that's the square root of -1 over the square root of 2. And on the top now I have I. On the bottom, I have a radical, and that's not okay. We have to rationalize that denominator, and we're going to multiply by the square root of 2 on the top and the bottom to eliminate that radical. So it will be x equals plus or minus I squared roots of 2, and then my denominator will be the square root of 4, because the square root of 2 times the square root of 2 is the square root of 4, and that will give me 2. And if we are to write this one in standard form, we will write it as the square root of 2 over 2i. That one is a pure imaginary number. It doesn't have a real part. It only has an imaginary piece to that complex number. The next one that I wanted to go through was 35, which is 3s squared plus 2 equals -62. So again, this one does not have an s term sitting by itself. So I'm going to go ahead and solve by isolating the variable. So we'll subtract the 2 from both sides, and then we'll divide by the 3, and we'll take the square root. So S is going to equal plus or minus, I'm going to go ahead and split these up right away, the square root of negative 64 over the square root of 3. So S is going to equal plus or minus, well, the square root of negative 1 is I, and the square root of 64 is 8. So that'll be 8I over the square root of 3. Now, the problem is, just like it was last time, I have to rationalize the denominator to get that radical out of there. So I'm going to have to multiply my numerator and my denominator by the square root of 3. So that will be plus or minus 8I square roots of 3 all over the square root of 3 times the square root of 3 is the square root of 9, which is 3. And if we are to write this in standard form, we would write it as plus or minus 8 square roots of 3 over 3I. And again, that would be a pure imaginary number that we get for a solution there. Now I'm going to have to go do some erasing here because I had another one that I wanted to show you on this page. So hang in there. And that is number 38 up here. So number 38 is negative 5x squared minus 3 equals 0. And again, I notice that I do not have a middle term, so I'm going to go ahead and add the 3, divide by the negative 5. And then I have to take the square root of both sides. So x will equal plus or minus the square root of negative 3 over the square root of 5. Well, I can do a little bit. On the top there, I can take out the square root of negative 1, that's I. So I, square roots of 3 over the square root of 5. And now the next part again is rationalizing that denominator. So I'm going to multiply my numerator and my denominator by the square root of 5. So x will equal plus or minus I, and then the square root of 3 times the square root of 5 is the square root of 15, over, and then we have the square root of 5 times the square root of 5, which is the square root of 25, which is 5. And if we wanted this one in standard form, again, basically what you're doing is you're just taking the I and you're going to put it behind the term. And that's because we are supposed to write it as A plus BI, but in these cases we don't have a real number part. We don't have an A sitting out in front. On the next page we are supposed to find the solutions. So 40 is negative 3x squared plus x minus 3 equals 0. And if I'm going to find the solutions of that, and it's not going to be done by factoring, what I need to do is complete the square. So negative 3x squared plus x equals 3. Move that negative 3 out of the way. It wasn't helpful over there anyway. And then go ahead and divide both sides by negative 3. So we'll have x squared minus 1/3 x equals negative 1. And now we have to go ahead and complete the square. And I'm going to put my box in there so I don't forget to do that to both sides. And my b value is negative 1/3. So the formula is b divided by 2 squared. But we don't divide fractions. We multiply by the reciprocal, so it will be negative 1/3 times 1/2, and that quantity squared. Well, you do top times top and bottom times bottom with fractions, so we'll have a negative 1/6 squared, which is 1/36. Why I wrote 1/13 down there. 1/36. So I have to add 1/36 to each side of this fraction. And you can always grab a calculator over there, but just think of this as a negative 36 over 36 to get you the negative 1. So that will be a negative 35/36. And in the parentheses, we need x and we need that b over 2 value, that value that we squared, and that was a negative 1/6 to give us that 1/36. Now we need to take the square root of both sides. So x minus 1/6 equals, sorry about that, the phone rang there. So I need the square root plus or minus the square root of negative 35 over the square root of 36. So it will be x minus 1/6 equals plus or minus I square roots of 35 over 6. And now the square root of 35 is not simplifiable, so what I'm going to do is just add 1/6 to both sides. So 1/6 plus or minus I square roots of 35 over 6. And if we want to write that in standard form, that will be 1/6 plus or minus, and then we'll have square root of 35 over 6I. like so. Now, I'm going to go after number 41. All right, again, I'm going to solve this one by completing the square. So I'm going to subtract the 7 from both sides. Then I'm going to divide by 2. So we get x squared minus 2x, and this will be a negative 7/2 over here. So now it's time to complete the square, which means I have to take a negative 2 and divide it by 2 and square it, because that's going to give me my b over 2 value, and that's going to get me 1. So I need to add 1 to both sides of this equation, and that will give me the binomial squared x minus 1. And on the other side, I would have negative 7/2 plus 2/2, because 1 is the same thing as 2/2. So that will give me a negative 5/2. Then I need to take the square root of both sides, and that will give me x minus 1 equals plus or minus the square root of negative 5 over the square root of 2. I can simplify that just a little bit by making it I square roots of 5 over the square root of 2. But the problem is, again, I have a radical in the denominator. So I need to multiply my numerator and my denominator by the square root of 2, and x minus 1 will equal plus or minus, and that will be I square roots of 10 over the square root of 2 times the square root of 2 is the square root of 4, which is 2. And then I would go ahead and add the 1, so 1 plus or minus I square roots of 10 over 2. And if they ask to have this answer written as a complex number in standard form, then I would need to write it as, and I made my fraction bar go too far here. I would need to write it as 1 plus or minus the square root of 10 over 2i, like so. Then I'm going to need to erase again, because I know I had another one up there that I wanted to go over. All right, so number 44 is 2x times the quantity x minus 3 equals negative 5. We would want to distribute that and get 2x squared minus 6x equals negative 5. And like I said before, I'm just going to solve these by completing the square. We're getting a lot of imaginary answers, so I'm going to go ahead and divide both sides by 2. And then I have to take my b value, divide it by 2, and square it. So that will give me 9/4. So I have to go ahead and add 9/4 to both sides. And I will get x minus 3/2 squared equals, a negative 5/2 would be the same thing as negative 10/4. So negative 10/4 plus 9/4 would be a negative 1/4. Then I have to take the square root of both sides. So it will be x minus 3/2 equals plus or minus the square root of negative 1 over the square root of 4. And that will give me, when I simplify it, x minus 3/2 equals plus or minus I over 2. And then I go ahead and add 3/2 to both sides. So it would be 3/2 plus or minus I over 2. But again, if they wanted this in standard form, I'd write it as 3/2 plus or minus 1/2 I, putting that I in the back. So these get, involved, but we deal with all of the pieces that we know individually and try not to think of it as some gigantic problem that we're doing. Then, number 58 says, the multiplicative inverse of a complex number z is 1 over z, where z is not equal to 0. Find the multiplicative inverse or reciprocal of each complex number, then use complex conjugates to simplify. Check each answer by multiplying it by the original number. So I have 2 plus 5i right now, and to get that multiplicative inverse, I need to put that in the denominator. Notice if you multiply those two together, you get 1. So now what I'm going to do is I'm going to have to simplify, rationalize my denominator here by using a complex conjugate. So my numerator is very basic. I'm just going to get 2 minus 5i. And on the bottom, I do first times first and get 4. Outside times outside plus inside times inside cancel out. but then I have a negative 25I squared. And then I remember, oh, wait a minute, you know, I squared is negative 1, so this will actually be 4 plus 25, which is 29. And in standard form, that would be 2 29ths minus 5 29ths I. So that would be the multiplicative inverse. Now, they want us to go ahead and check and make sure that this is in fact going to work. So if we take 2 plus 5I over 1, times 2 minus 5I over 29, this is supposed to work out very nicely. So if we do FOIL on our numerator up there, we're going to get 4 minus 25I squared over 29. And then, of course, I squared is negative 1, so it'll be 4 plus 25, which is 29 over 29. And that shows that what we got was the multiplicative inverse, because that's what multiplicative inverses are for. When you multiply them times a number, if they are the correct multiplicative inverse, you're going to get a 1. Then this one says, show that the product of any complex number a plus bi and its conjugate will be a real number. So if I multiply these two together, I will get a squared minus abi plus abi, and then minus b squared I squared. Well, you notice the two middle terms are going to drop out, and this I squared is a negative 1, so it will be a squared plus b squared. And if a is a real number and b is a real number, then a squared plus b squared will absolutely be a real number. You will stay within that real number system when you do that. Then number 73 says, how could we rewrite a minus 5I, that quantity squared, in the form a plus bi? So with this one, we must multiply it out twice, because notice that power is to the left of the parentheses, and that's telling us everything in the parentheses gets written down twice. So we do first times first, outside times outside, inside times inside, or maybe, you know, we think ahead and say, oh yeah, this is where outside times outside, inside times inside end up being exactly the same. And then last times last. So that will give us 64 minus 80I, and then minus 25, because that I squared is a negative 1. So then we need to take our little 64 minus 25 and get the answer of 39 minus 80I. And that's answer B. And I do believe, oh, I have one more here. Solve each equation using the quadratic formula. So 78 was 4x squared plus x equals 1. Remember, when you use the quadratic formula or the discriminant, you have to have a 0 on one side because you're solving. So A is 4, B is 1, and C is negative 1, and x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's see what we have here. X will equal negative 1 plus or minus the square root of 1 squared is 1 minus 4 times 4 times negative 1 all over 2 times 4 is 8. Now we're going to go ahead and figure out what we have underneath that radical there. And we have two negatives, so negative 4 times 4 is negative 16. Negative 16 times negative 1 is positive 16. So 1 plus 16 is 17. And I'm just going to shorten my radical symbol up there a little bit. That's as good as it gets, because the square root of 17 is not simplifiable. And that should take care of 4-8 day 2.